Okay, so looking at oblique asymptotes are really also called slant asymptotes. So it's not horizontal, it's not vertical, it's on a slant. The way that this happens is when the numerator is 1 degree higher than the denominator. Okay, now there's a little bit to this, but what you essentially have to do is divide, using long division, the numerator divided by the denominator, and whatever we get as our divisor is going to, as our dividend, is going to be our slant asymptote. So for an example like this, if we're looking at this equation here, okay, and we do the long division, which we've shown here, okay, what we're going to find out is that our slant asymptote is f at x equals x minus 1. Okay, we don't have to worry about the remainder can kind of go away, and we're just dealing with this value, the equation. Okay, so what we're looking at in this bottom one is we're going to do the division. So x squared minus 4x plus 2, and then 2x cubed minus 3x squared plus 2x minus 7, and we do the long division. The way you know if you have to do this is if we have 1 degree greater on the top than we do the bottom. Okay, if they're the same, then we know we have a horizontal asymptote. If they are not the same, then we have to check, are they 1 degree different? So here, we're just going to then go through the long division. So we've got 2x, so that's going to be 2x cubed minus 8x squared plus 4x. Okay, and it's subtraction here. It's different than our synthetic, so we're left with 5x squared minus 2x, bring down the 7, and then we get plus 5. So we get 5x squared minus 20x plus 10, which is 18x minus 17. Now this degree is smaller than what we're dividing by, so we know we're done. So then therefore our slant asymptote is whatever's on the top here. So therefore our slant is f at x equals 2x plus 5. Now the unique thing about a slant asymptote and actually a horizontal asymptote is that your graph, when you get higher degrees, can actually cross over it. Now I'm going to show you what I mean by that, and I'll show you an example here. This graph won't, but what we're going to actually look at is a case where it can cross over. So first thing, we've got x squared minus 2x minus 5 over x minus 1. So first thing, find your vertical asymptote. So we set our bottom of the equation equal to 0. So our vertical asymptote is x equals 1. So let's put x equals 1 on the graph. X equals 1. Okay, next, can we do horizontal asymptote? Well, we can't because the degree isn't the same on the top and bottom. Okay, so regardless of what the bottom is, the top is always going to be infinitely bigger than it, so we can't have that. So what we need to do then is an oblique asymptote. So we're going to do x minus 1, and we're dividing it into x squared minus 2x, I believe it's minus 5. So then we get x, that's x squared minus x, that's going to be x minus 5 plus 1, x minus 1 is minus 4, and now we're done. So our oblique asymptote is f at x equals x plus 1. Okay, when we're doing that, we're going to go to our y-intercept, because this is in y equals mx plus b, and we're going to use our slope. So we have a y-intercept of 1 and a slope of 1 over 1 here, so it's going to be something like this. Okay, and what that actually tells me is this point right here is negative 1. This is 1. This is f at x equals x plus 1. I know that this right here is negative 1 because we're going up 1 over 1 to the right, or we're going down 1 and over 1 to the left. Okay, and that's from my y-intercept. Next, our y-intercepts for the actual function, we're going to set x equal to 0. Well, that one's actually pretty easy. Y equals x equals 0, everything in the equation except for the 5 and the 1 go away. We have negative 1 over negative 5. Now the x-intercept's a little bit harder because we're setting y equal to 0. Okay, if we set y equal to 0, what we're doing is we're making x squared minus 2x minus 5 equals 0. You would factor that normally, but this doesn't factor. So we'd put it into the quadratic formula. What you're actually going to find is that x equals about 3.44 or x equals negative 1.45. Okay, you should be able to put it in the quadratic formula and find the exact numbers with the square roots. But I always like to use a decimal because now I can actually see roughly where we're going to be. That's negative 1.45. This is 3.44. And we've got our y-intercept of 5. Okay, that's going to show me the general shape of the graph. Now if I were to check my end behaviors, as I get close to negative, or as I'm less than negative 1, or less than 1, sorry, it's going to go up like this. As I go to infinity, that's going to go down like that. As I get close here, I'm going to negative 1 and positive. So this, as we get, is going to, so f at x is going to infinity, f at x is going to negative infinity, and that's just by plugging in numbers that are really close to 1, both on the positive and negative side to the equation. Now the last question says, does this graph cross over? Now this one doesn't, but what we have to do is we know that the equation is x squared minus 2x, what is it, minus 5 over x minus 1. What we have to actually do is to find out if it crosses that line is we have to set it equal to that line. Okay, and then solve. If we can solve for a value, if we can get x equals something, then the graph actually does cross at that value of x. So what we would do, so our slant asymptote is x, so f at x equals x minus 1. So then when I solve this, we get x squared minus 2x minus 5 equals x squared. I'm multiplying this to the other side, minus 2x plus 1. So when I simplify this, I get negative 5 equals 1. So I can't actually solve it. So can't solve, there's no way of doing this, so no. Therefore, no. But what if we had something like, we'll just put in a fake example here, but if we had same exact thing, so x squared minus, let's say it was 3x minus 5 over x minus 1. So all I did was change that middle term. We've got x minus 1. Well, I'm going to get x squared minus 3x minus 5 equals x squared minus 2x plus 1. Well, now when I simplify it, I'm left with, if I move all of the x's to the left, I would have negative x equals 6 and x equals negative 6. Because the slant asymptote was this, we're going to plug x equals 6 into, or sorry, negative 6 into that, so we get f at negative 6 equals negative 6 minus 1, which is negative 7. So therefore, it would cross, it crosses at negative 6, negative 7. Okay, and that's just an example of when it would cross. It can never cross a vertical asymptote. Graphs can cross, as the degree gets higher, graphs can cross horizontal and oblique asymptotes. So we need to check. We need to set the equation or the function equal to those values and check if they're going to cross or not. And they're going to create a little bit of a weird function, but it's typically, when we do that, we're going to have some sort of symmetry. So whatever it was before that point is going to be the same thing reflected after that point.